So in this video, let's take a look at this LeetCode question. Question number is 234, palindrome linked lists. So let's understand first what is the palindrome. Okay, so palindrome is a thing which is only applicable on the linear data structures like linked lists, array, and strings. So if I take an example of a string, race car is a palindrome. Why it is palindrome? Because if we from the write it in the reverse order, so it will be equal to the original one. Okay, like you can see that the first character and the last character of this string is equal, and the second character and the second last character it is also equal, and the third character and the third last character is also equal, and this middle it doesn't matter. Okay, so this race car is a palindrome string, and if we take an example of an array, so 1, 2, and 1. So you can see that element, last element and the first element both are the equal, and this middle one is also equal. Okay, so this array is also an palindrome. Okay, in case of linked lists, we have to find that if the given linked list is a palindrome or not. In the example number one, you can see that we have given a linked list. So you can see that the first node has the value 1 and the last node has the value 1 also. Okay, and the second node it also has the value 2, and the second last node it also has the value 2. So this linked list is also a palindrome. Okay, so we will simply return true. And in the example number 2, we have only two nodes in the list. Okay, so first node has the value 1 and the second node value has 2. If we reverse this list, so the first node will be 2 and the second node will be 1. So it is not same as original. So we will just return false because this is not a palindrome. Okay, and if we take a look at the constraints, the number of nodes in the list is in the range of 1 to the 10 to the power 5, and the value is going to be from 0 to 9, single digit. And we have to write an algorithm which takes time complexity of n and the space complexity big O of 1, means constant. Okay, so now let's understand how we are going to do this question. So you can see that we have here a linked list with the 4 nodes. So the first node has the value 1, and the second node has value 2, and third node has the value 2, and the fourth node has value 1. And fourth node's next property, it is pointing to the null, representing the end of the list. Okay, and every linked list has a head pointer, which is pointing to the first node of it in the list. Okay, so what we are going to do to solve this problem, we will just divide this list into part, and we will simply reverse one part, and we will check if the last node and the first node are has the equal values, and the second node and the second last node has the equal value. Then it is the palindrome, and we will just return true. Okay, so for the reversing the linked list, what we are going to do is simply use slow and fast pointers. So why we are using slow and fast pointers? So slow is going to move with the one node ahead, and the fast is going to move two nodes ahead. Okay, so when the fast is pointing at the null, then or slow is somewhere around the middle at the middle of the lists. So using the slow and fast pointer, we will just reverse the half of the node. Okay, so we are just defining slow and fast pointer with the first node. Okay, so initially slow and fast both pointers are pointing at the head node of the list. Okay, and we are also creating a previous node which is initially pointing at the null. And what we are going to do here is we will just run a while loop while fast is not equal to null. So in this case, fast is pointing at the first node, so it is not a null. So while loop will run, and what we will do is simply we will just increment the fast pointer with two nodes. Okay, so fast node, no, fast pointer is pointing at the first node. So it will just we will just increase this fast pointer to the with two steps. Okay, okay. So when we increase the fast pointer with two nodes, so fast pointer will be pointing at the third node of the linked list. Okay, so now what we will do is simply we will change the link. You can see that uh, first node's next property is pointing towards the second node. So what we will do is we will change this link and we will just reverse this link to the null. Okay. So what we are going to do is simply slow pointers dot next is going to point at the previous pointer. Previous is null because here. So we have just changed the link and we also have to keep track of this second node. Why? Because when a no pointer is pointing to the second node, so the garbage collector will collect the node. Means it will just get deleted in the Java. Okay, so we have to keep track of this node. So we will just create a temporary pointer which will point at the slows dot next pointer, which is this means next node, which is this second node. So we will just keep track of this node with a temporary pointer. Okay, after changing this link, increase we will just increase the previous and slow pointer with one step. Okay, after increasing previous and slow pointer with one step, so the scene is going to be this. Fast pointer is pointing at this third node. Slow pointer will be pointing at the second node, and the previous will be pointing at the first node. And the first node's next is pointing towards the null. So here you can see we are just reversing the linked list. Okay, next what we are going to do is so the loop will iterate again. Why? Because fast is still not equal to null. Okay, so we will just increase fast with two steps. So the fast will go from here and then here. So fast will point at the null at the second iteration. Okay. Then what we will do, we will change this link. Second node is pointing towards third node. So we will just change it, this pointer towards the previous pointer. Okay. So the second node's next field is going to point at the first node. So we are just reversing the links. Okay. And we also have to keep track of this third node. Why? Because we when we change this link, so no pointer is pointing to this third node. So we have to create a temporary pointer which points to this third node. So it don't get deleted from the memory. Okay. So now we have changed the link and we also have to uh, update the previous and slow pointers with one step ahead. Okay. And after updating this, so previous is going to be point at the second node and the slow is going to point at the this third node. Okay, so the final scene is this. In the third iteration, you can see that the first node is pointing at the null. So the loop is not going to run anymore. And you can see that we have two linked lists. First one is the first half part of the original linked list, and its head is or previous pointer. Okay, and the second list is another half part of the original linked list, which is going to start from the this slow pointers. Now what we have to do is simply run one more loop and check until this slow pointer is not null, and we will just compare this node's value and this node's value. Okay, if this node's value and this node's value is not equal, then we will just return false because it is not going to be palindrome. And if it is equal, we will increment this both of pointers one step ahead. So slow is going to point at this one and previous is going to point at this point, is at this node. Okay, and we will check again if it has the slow node has the value, slow node's value and the previous node's value is equal. If it is equal, then we will just increase the slow pointer with one step and previous pointer one step ahead. Okay. So after incrementing these both of pointers, so the last scene is going to be like this. Okay. So previous pointer is pointing at the null and the slow pointer is also pointing at the null. So we will just break out the loop. We will just return true because there is no nodes to compare. Okay. While comparing, If any node has a not equal value, so we will just return false from there. Okay, so this is the case when we have a even number of nodes in the list. What if there is a odd number of nodes in the list? So let's see that case also. So again, we will initialize three pointers: slow, fast, and previous pointer. Previous is initially at the null, and the slow and fast pointer is initially at the head node of the list. Okay, so we'll just run a while loop while fast is not equal to null, and we will just increment the fast pointer with the two steps. So when we increment the fast pointer with the two steps, so it will pointing at the this third node. Okay, so first pointer is pointing at the third node, and what we have to do is simply change this first node's next field with the null. We are just reversing the links, and also we have to keep track of this second node. So we have just created a temporary pointer which is pointing to this point. Okay, so we have just changed the link, and we also have to increment the previous and slow pointers. So after increasing the previous pointer, so previous will just point at the first node, and the slow will point at the second node. So inside the while loop, we will just write one more if condition. If the first dot and next is null, then what we will do, we will just increase the slow pointer with one step and break the loop. Why we are doing so? Because there is no more node to reverse the links. Okay, so if that is the case, so what I have done here is I'm just increasing the slow pointer with one step and breaking the loop to check if these both values are equal or not. If this both nodes has had the not equal value, so we will just return false. If it is equal, so we will just move ahead. Okay, after increasing previous and slow pointers, we can see that previous is pointing at the null and the slow is pointing at the null. So we will just break the loop, and we didn't found any nodes which is not equal and which didn't have a not equal value. So we will just return true at the last. So now let's see the code. So here you can see that we are defining the three pointers here. First is a slow pointer, which is pointing initially at the head pointer, head node, and the second is the fast pointer, which is pointing at the head node of the list initially. Okay, and we are creating the third pointer, previous. Okay, and which is pointing at the null initially. And we are running a while loop while fast not equal to null. I have just written a if condition. If the fast dot next is equal to null, then what we will do? We will just increase the slow pointer with one step and break the loop. Why we are doing this? Because there if there is an odd number of elements, like let's take an example of array. So let me take this example. So you can see that there is an odd number of elements inside this array. So I just have to compare this first value and last value, the second value and the second last value. If we can't just compare this third value with itself. Okay, so it doesn't matter if we just remove this third element, it is still a palindrome. Okay, so I'm just not comparing the middle element, I'm just skipping the middle element. That's why I'm doing this. Okay, so if the fast dot next is equal to null, then we will just increment the slope pointer with one step, and we will just break the loop. And here we are incrementing the fast pointer with two nodes. Okay, so fast dot next. Okay, incrementing fast pointer with two step. Okay, and what I'm doing here is creating a temporary pointer which is pointing initially at the slow dot next node. Reversal here. Okay, and after I'm changing the link, slow dot next field is going to point at the previous node. Okay, and after doing changing the link. Okay, after changing the link, what I'm doing here is simply updating the previous and slow pointers. So the previous is going to point at the slow pointers, The slow pointer is going to point at the temporary, and inside the temporary we have slow dot next node. Okay, after executing this while loop, we will just apply one more while loop to check the corresponding values of the nodes. So while slow is not equal to null, we will check if the previous dot value is not equal to slow dot value. Okay, previous is the pointer where the first node, first half of the linked list starts, and slow is the pointer where the last part of the linked list starts. Okay, so we are just comparing the value. If it is not equal, we will just return false from here. So if not a palindrome, then simply return false. Okay, and then just increase the slow pointer with one step and previous pointer with one step. And after running this while loop, this if condition is not triggered, it means the linked list is a palindrome. So we will just return true here. Okay, so this is the code. And if we discuss about the time and space complexity of this algorithm, so we are just traversing through the linked list once only. So the time complexity is going to be linear and the space complexity is going to be constant.